Welcome. In this lesson we will talk about LOI and study calcia contributing materials specifically. We'll discuss what makes frits such great sources of oxides, the concept of alternate sourcing in oxide, non-participant recipe materials, and the Digitalfire material information strategy. We are going to take a closer look at the makeup of calcium carbonate, also called whiting. To more fully understand this material, it needs to be alone in a recipe. I will select the Custer feldspar line in Recipe 1 from Lesson 1b and click the Delete button to remove the amount of the feldspar. That leaves only the whiting in Recipe 1. Before continuing, I should point out that the calculated molecular weight of calcium carbonate is 100, by a rather amazing coincidence. Hopefully that will reduce a little confusion in this lesson. Notice the formula weight INSIGHT calculates for whiting in the calculated items list, 56.1. If I double-click the whiting recipe line, the materials dialog shows a weight of 100. Why is that? Well, calcium carbonate powder is not pure calcium oxide. It contains carbon dioxide. If 100 grams of calcium carbonate powder are put into the kiln, only 56.1 will be present in the fired glaze. The rest is lost as CO2 vapors. Here you can see that INSIGHT calls the 43.9% loss LOI, literally loss on ignition or weight lost on firing. Here is the other 56.1 that is left. Of course, if I double-click CaO to see it in the oxides dialog, its weight is 56.1. When INSIGHT calculates, it is portraying only what is left after firing, and it gives us the weight of that. There is no CO2 in the formula list. It's gone. So the materials dialog is representing raw materials with LOIs. The recipe window is showing us only the calculated products. However, notice that INSIGHT actually displays two different LOI figures in the recipe window, the calculated LOI and the imposed LOI. I will demonstrate. But before going on, note that I have the lessons materials database selected as with other lessons. I've closed the materials and oxides dialogs and will choose Override Calculated LOI in the Calc menu. Notice this window already knows that my raw recipe has a total LOI of 43.9. So I'll set it to that. INSIGHT now calculates the correct weight for the raw material, and the override I just set is displayed as the imposed LOI. Being able to impose an LOI is important to adding new materials to the materials database. As you will learn, when materials lose this much weight during firing, they generate a lot of gases. This can have an impact on the glaze, especially if the gases are coming out as bubbles after melting starts. There are sources of CaO without such a high LOI. I'll show you in the materials dialog. Notice on the lower left there's a pop-up list where you can select an oxide. I've selected CaO. As you can see, it is obviously sourced by many materials. I'll scroll down the list and show you wollastonite. Notice it contains equal CaO and SiO2. Of course, this is a theoretical material. Real-world wallastonites have traces of other things, and the SiO2 and CaO are not exactly equal. Like a feldspar, getting SiO2 for a glaze this way is better than from raw quartz powder. Notice also this has no LOI. Want to learn more? Level 2 INSIGHT users can click this button. Here's dolomite. This is actually worse than calcium carbonate. It loses 47.6% on firing, leaving 53.4. This formula weight, 96.4, is thus 53.4% of the formula weight of the raw material. When we talk about LOI, we also need to think about when the gases are liberated during kiln heat-up. If it happens after the glaze starts melting, that is obviously not good. The Digitalfire reference library has a special area called temperatures. It is attempting to map the decomposition events from many materials during kiln firing. Here's a boron frit. Notice that it has 20% CaO. If your glaze also needs sodium, boron, and silica, and the vast majority of glazes do, a frit like this is a good source of CaO. INSIGHT is a great way to figure out how to juggle things to incorporate frits into glaze recipes while maintaining the chemistry. The really great thing about this material is that no feldspar on Earth can offer this, no alumina. That makes more room in recipe for clays. They are sources of alumina, and they suspend the slurry and harden the dried layer. In addition, frits generate no gases on firing. A recipe can contain materials not known by INSIGHT. We call these phantom or non-participant materials. To demonstrate, I've entered a line with 50 parts of spider's legs. The asterisk before it means INSIGHT cannot find chemistry for it. Organic gums are like this. They are added to glazes to impart working properties but contribute no oxides to the fired product. They just burn away. When doing glaze chemistry, we most often like to see a clean formula, not cluttered up with colorants or opacifiers, for example. Thus, you will actually want to leave materials like zircon or tin oxide or raw coloring oxides or stains out of your materials definition table and enter them into glazes the way I have done with spider's legs here. I want to talk for a moment about how we decide what materials to include in the standard list. Of course, the lessons materials database, the one we are using here, is small, but the standard one distributed with INSIGHT normally has about 250 generic and name brand, mostly North American materials. The MDT section of the Digitalfire reference website explains the logic behind how we determine which materials to include in the starter tables that are available for various parts of the world and specific ceramic industries. There is a page where logged-in INSIGHT Level 2 users can add to one of the starter databases and customize materials names and even translate them. This page at the Digitalfire reference library is where we focus our material information efforts. These links and this search are the home page for thousands of materials. This link goes to the area where we were just looking at, and all of these others are interrelated in a material-centric reference database. We will be using this resource much more in subsequent lessons. That is the end of this lesson.